In the quest for clean and renewable energy, people often talk about wind or solar power, but these aren't always very efficient since they can vary from generating too much power to not generating enough power. We need an alternative that is clean and reliable at all times. Some solutions have been hydroelectric or even nuclear power. But did you know that there's something that's accessible around the world right under us? In fact, we've known about it since at least the 3rd century BC, when the Qin dynasty built a spa over a hot spring to use it as heating. It was also extensively used in England by the Romans in the 1st century AD to heat public baths and even some buildings with underfloor heating. Yes, I'm talking about geothermal energy. There is a near limitless supply of heat that we can use as energy held within our planet. The core of the Earth holds an insurmountable amount of energy originating from when the Earth originally formed about 4.5 billion years ago. This energy has been created from gravitational forces, and some energy continues to be created from friction as the layers shift against each other, and radioactive decay, creating a constant upward flux of heat from inside the Earth. There are multiple ways to then harvest this energy and convert it into electricity for our own applications. For the most part, these come in the form of vapor-dominated or liquid-dominated forms. The Geysers is the world's largest geothermal field. Located north of San Francisco, California, it uses steam from, well, you guessed it, geysers to generate power. It utilizes a dry steam power plant, pulling steam through a turbine to generate electricity before pushing it back underground. Liquid-dominated reservoirs, or LDRs, are most commonly found near fault lines and thin spots on the Earth's crust, where temperatures exceeding 200 degrees Celsius can be found. However, since this source is usually at such a high pressure, it's often actually water that's being drawn out, and a flash tank is used to quickly expand it to a lower pressure and hence lower boiling point to then convert it into steam, where it can then be used on the turbine to generate power. However, both of these solutions require sources of a relatively high heat to work effectively, which may not be found all throughout the world. To solve this, there is a method called a binary cycle power plant. This draws hot water from the ground, goes through a heat exchanger, which then gives heat to a working fluid with a much lower boiling point, like for example pentane, which has a boiling point of 36 degrees Celsius. This allows the turbine to be used to generate power at a much lower temperature. This is very useful for the many places around the world who don't have hot spots to easily access high heat. Finally, enhanced geothermal systems, or EGS, manually inject water into the wells so that it can be heated and is then pumped back out. As we drill down and pump water into the ground, a network of cracks are formed in which heat is exchanged to the water under pressure. We then can drill another hole to pump the water back out. This is similar to the controversial oil extraction technique fracking. However, this goes even deeper and uses no toxic chemicals, which reduces the possibility of environmental damage. So, if there's so much energy available, why isn't it being used so much? Well, according to reports, of all the geothermal sources available right now, only 7% has been used. In the United States, there's less paperwork and fewer approvals required for drilling for oil than drilling a geothermal well. According to a study from the National Renewable Energy Laboratory, it usually can take about 8 years to do environmental studies just to start a geothermal project. In addition, wind and solar projects get a tax credit of 30%, while geothermal only gets a tax credit for 10%. This is because back in 2005, when Congress passed a law for environmental regulations, they, quote, didn't think to include geothermal, and it's been the same ever since. Finally, drilling is very expensive, and it's just hard to get people on board to invest in it. Hopefully, with further investment in engineering into new drilling technologies and ways to harvest geothermal energy, and possibly more forward-looking politicians looking into overhauling the regulations for geothermal energy, we can have a much brighter future with our energy coming from right under our feet.